Good afternoon, Jan.
Michael, good afternoon. We are back in sync.
Yes, we are. Yes. Yep. Sorry
Uh,
about the mix-up last time. I'd forgotten that we had changed time zones the week before, but
mm,
that was intended to be a solo anyway, so I just didn't notice it.
and we changed last week. No, it's incredible why these changes and then on different moments.
Mm-hmm. Yeah,
Uh,
yeah. Historical reasons that don't make sense to anybody. But
mm,
yeah, hopefully that will be a thing of the past.
I'm afraid not.
Yeah. Yeah. We've got the what are they calling it? The Sunshine Protection Act in the states. Um,
Mm.
so now we're going to protect the sunshine. So,
So you
uh,
will be staying on summertime then.
yes, that is the intent.
Okay.
Um, so yeah, apparently it's passed the Senate. It's in the federal at the federal level. The House has yet to vote on it, and it's very likely to be signed into law. Yeah.
I think in Europe not yet. Some regions want to be on winter time. Some regions want to be on summertime.
Yeah,
Um,
that's fine.
so I don't think they will agree for the moment.
Mm-hmm.
Michael, I saw the business agility from when I was on training
Yeah.
and the secrets from last week.
Uh huh.
And I saw something like SQL generation for today,
Yes. Yes,
but
indeed.
I still have a lot of questions about the secrets.
Okay. Well, let's start there because I'm having some trouble getting the .NET Interactive Notebook opening on this machine, so it's going to be difficult to go through that unless you share the notebook. Maybe it'll open on your machine. But going from .NET 6 to .NET 7, um, uh, I haven't yet updated all parts of this machine for .NET 7.
Yeah, thought, I thought I was on 7, and that it worked fine. Um, was it
Okay.
from 5 to 6 or from 6 to 7? Maybe
Yeah.
it should be
Yeah. I
from
don't know.
6 to. Well,
But yeah, let's
anyway,
start with the secrets.
um, the first part, yeah, again overwhelmed
Uh huh.
because there you get all the Azure technology. So that's again something you have to know in depth before understanding what's
Mm-hmm.
going on. But then the second part um, is very interesting. So the web application itself to create a replicator
Mm-hmm.
is made in Jinaga itself. Is that correct?
Yes, that's correct.
Okay. And there you show the developer tools in Internet Explorer or in
Mm-hmm.
Edge. There you get the timings. And that's in fact
Yes.
the first time that we have a real application where the whole communication protocol is used, including the feeds and so on.
Correct. Yes.
Um, you went over it quite fast. On top of that, you focused on the 100 milliseconds.
Mm-hmm.
Um, I don't really understand um, where that additional information would come from because you only have one client, you have one server. But I would like to go through in depth through the protocol because you have the feeds there, you have the load.
Mm-hmm.
This would really be a practical case, a first practical case to really understand the protocol.
Yeah.
Um,
Okay. So
so
I've got the application running again here, so I can share and we can take a look um, at that waterfall.
mm,
All right. So there's the waterfall, or there's the application.
Yeah.
Okay.
And
So
so the model for this, because I didn't find it in GitHub. This one, is it not on
that's
GitHub?
correct. This one is not on
Okay,
GitHub.
okay.
Yes,
The model for that one, do you have that one available?
I do. Yeah, this is. Oh, okay. Hmm. Yeah, it might be all of WSL that's not working for me. Hmm. Let me shut down VS Code. Um, this was me trying to update .NET just a moment ago. So let me go to
Yeah.
projects, Jinaga, and then this one's app Jinaga.com. And let's see if we can open it. Okay, so definitely having some trouble with VS Code. Yeah. Okay. Yeah, that might be an issue. Well, we'll do this the old-fashioned way. Let's just take a look at. So this one is uh, the typical client server type of application. So we've got the client and the server and the shared. So go into shared, and that's where the model is. And so we've got index, replicator, and user. So index just exports the replicator and user model. It builds the two of them together. So the interesting one is replicator. So there is the replicator model. Okay. Yeah, so it's a pretty small model at this point. So
You don't have it in graphics.
no, well, I wouldn't be able to. Yeah, I wouldn't be able to open that up right now.
Huh?
Visual Studio Code is not happy with me at the moment. It's probably going to take a reboot. But yes, we've got a replicator that has a string identifier, and I use a GUID in order to satisfy that one. And it is owned by a user. So then we've got the mutable property pattern for replicator name,
Okay.
and also for replicator environment. So
That
environment is
was work, develop, production. Yeah.
yes. So I have right now 3 different environments: dev,
Yeah.
test, and production. And then
Okay.
we've got the deleted pattern.
Okay. For close to deleted.
Yep. And this one does not have the restored
Restore.
option, so
Yeah.
it doesn't have its own separate timestamp for the deletion. So I'll update that before I actually release this for production use. Should definitely be able to restore a deleted replicator. And then there's the overall description where it's building the model out of those classes, wiring everything together.
Okay.
And we've got our authorization rules. So a user can create a replicator. The replicator user can name the replicator and set the environment, and the replicator user can delete the replicator. I love how simple these authorization rules end up being now with this new specification language.
Indeed. All right. So actually, the model is quite simple.
Mm-hmm. Yep.
That user is a predecessor of a replicator.
Yes. Yep, so that
Okay.
gives us this thing. And now in order to, let's see, in order to to find all the replicators for the user, let's go back out to the client side. And in here we have the replicators components. So we've got a replicator page. So we'll look at replicator page TSX. And in here, we have a specification. Yeah. Wait, no, I'm sorry. This is for one replicator. I want the list of replicators. So it's the replicators page. So cat replicators plural page. There we go. So right here is the specification for the list of replicators.
Specs of type replicated join. Deleted, select replicator, and then you get the hash identifier.
Mm-hmm.
The names, yeah, and the environments.
Yes.
Okay.
Yep. So all the replicators where not exists a deletion. The hash of that replicator, the identifier for the replicator, and then names using mutable property pattern. These are always multiples. They're always collections. These are the current values, the candidates for the names. So when I use the name, so I've got the name projection, that's where we come down here to use specification. So it takes a look at the observable collection for those names, and whenever a new one is added, it just replaces the name in that projection. So it just says, pick one. So if you do have a concurrent edit, then only one of those two names is going to show up in this list here.
You could have two. Yeah.
Yeah. Yeah. In fact, you could produce that
3 or 4.
Yeah, I can go into Monster Hotel and then duplicate this tab, and then if I edit here and I say Monster Hotel 1 and save that, and this one concurrently I do Monster Hotel 2, then when I go back to the replicators, it's kind of a toss-up which one of the two it gets. So that's funny. Yeah. This actually makes a lot of sense that the one who set it to 1 gets 2, and the one who set it to 2 gets 1. And that's because it's basically doing the last writer wins pattern there. So the last one to hear about, that's the one that overwrites the previous one. And of course, you hear about your own first, and then you talk to your peers, and then you hear about them.
Yeah.
So yeah, in this situation, you always lose. But yeah, that was just a kind of a quick and dirty way of getting the name up there. And if you don't have any concurrent edits, then everything is fine. But yeah, if you do, then strange things can happen. So
that means that the moment that you change it, it's not immediately sent to the server.
It is immediately sent to the server, but the other tab does not immediately fetch it from the server. I don't have the real-time subscriptions set up. Yeah, I didn't feel that for this application, real-time subscription was important. At least not for creating and naming replicators. Um, a place where I probably will set up those real-time subscriptions is when there's something on the back end that is updating a replicator. We'll do that in real time so that you see when it's ready for you. Um, also, um, well, yeah, as far as statistics, like how many facts are in that replicator, how many people are hitting it, over time, that kind of thing. For those, I probably won't do real time. I'll probably do polling, so that every 10 seconds it'll update the graph or something like that.
Okay.
Yeah.
So that will all be part of that application then.
Yes. Yep. And this will also be the place where, in addition to this card here, there will be other cards that give you source code that you can use. So you say, I'm building a React Native application. Oh, okay, here's a card that that tells you how to configure a React Native application to use this replicator. Here's another card that tells you how to set up authentication. So you'll come up here and you'll say, okay, I'm going to sign in with Apple. So, all right, give me your Apple developer identity. So sign in with your developer ID, and then it will configure an application in Apple. Exchange those secrets, keep the secret here, and it says, all right, now copy and paste this code into your React Native application, and then they'll be able to sign in with Apple and access this replicator.
Okay.
So that kind of thing. All of those things will be up here.
Mm. So now if we go to the main page again and we do a refresh.
Yeah, so it's a toss up which one we get. So here we got a 2. If we refresh this one, we'll probably get a 2 as well. Yeah.
Okay. So there we see the whole waterfall.
Mm-hmm.
Can we go through that step by step?
Yeah, indeed. So starts with hitting the page. So that's the HTML. Then we've got our JavaScript. These two are for the developer experience. But that one right there is the whole bundled application plus Jinaga JavaScript. Everything is in that one bundle. But then the interesting stuff starts with the XHRs. So here we log in. And so that's just simply saying, for this particular session cookie, give me back the Jinaga user. And so we've got the profile and the user fact. So there's the hash, and then there's the whole public key.
Why is this login happening again? We have post joining.
Let's see. So, why is the login happening again? I only see one login here.
Yeah, but what we did was just a refresh, and you were
right.
already logged in as Michael L. Perry before.
Mm-hmm. Okay, yeah. So yeah. I guess login is probably not the correct name for it. So it's not that the user is logging in, because that is in this application an HTML based exchange. So this is logging in with GitHub. So it uses OpenID Connect
Mm.
or OAuth 2 in order to redirect you over there, log in with GitHub, redirect back, send you the secret, all that stuff. So yeah, the login has already happened, and that created a session. So we've got
Yeah.
our session cookie from GitHub. But
Okay.
the thing that has happened here is that based on that session, um, we we said, okay, I already know that I've allocated a key pair for you, so let me put together the user fact for that public key and send that back to you. And I do want to say hello, welcome to the stream. We are going over the protocol for the Jinaga replicator as a service application. So yeah, if you have any questions or want to have talk about any topics, then please let us know.
Thanks. I'm just thinking again about immutable architecture, so I figured drop in and watch the stream.
Awesome. Welcome. Yeah, so this gives us back the user fact, and now the application can start doing its queries from there.
Yeah. So actually, the first time you logged in, that user fact was automatically created on the server, on the Jinaga server,
Yes.
based on the login data that you got from GitHub.
Yes, exactly.
Yeah. And
Yeah.
so now, because we refreshed, we just got the display name, the username back as the first fact that exists. Is that correct?
Yes.
Okay.
Exactly. So now that we've got that first fact, then we run the query. So here's the payload to get the names for that Jinaga user. So these two queries are actually functionally the same. So in fact, I do want to do one more optimization where I recognize that as far as the server is concerned, these are the same query. The projection of getting the user name fact versus just the string value out of that username fact, that's all happening on the client side. So the server is going to treat both of these requests the same way.
Michael, but why are we asking for the username here, while in that first request you already got the hash and the username?
Yeah, excellent question. So yeah, we look at the profile and we look at the the fact. So so the profile is coming from GitHub. So so yeah, because we have a session that that connects to the GitHub identity server, GitHub responds with some basic profile information about the user, and so we have in our database, in our replicator, a I'll just say database for right now, just to not to confuse with what the application is actually doing. But within our database, we have some username facts, which in the past were set up with that particular username. But if somebody goes into GitHub, changes their name, and then logs into this application again, we'll get a new display name, but it won't yet be that display name inside of our database. So the thing that that you're not seeing here is that the application compared, or actually is about to with these particular feed calls. It's loading the username facts and then comparing this display name with the name that it already knows about.
Okay. So the display name is what we get on top there?
Yes.
And yes. Why is Jinaga still comparing that display name with the name in the Jinaga database.
Yeah, if that display name is different, then it's going to generate a new username fact and put that into the Jinaga database. So every time you log in, it updates your name if it has changed.
So if the name we get back from GitHub is different, we will automatically create a new name fact in Jinaga.
Yes.
So we will store that new name as a successor of the user fact.
Yes, exactly.
Okay.
So I know I'm missing a lot of the context. So the user information is also stored in an immutable fashion. And would that
Yes.
let you sort of like go back in time and see Jan was Mr. Jan until today when he decided just to be Jan?
Uh-huh. Yep, exactly.
Okay. All right.
Yeah, and I can, Visual Studio Code is not working for me, so we're doing the old school observation of code. But if I go back to client, we've got this is going to be inside of providers. Oops. We've got a user provider. So let me take a look at the user provider. And you can see that this React component, when it starts up, it's going to wait for my mouse to come back. There we go. It's going to call login, and so that's what we saw here, was that call to login to the server. That gave us the user fact and the profile. And then it's going to query for names of user. And here's the specification for names of user. Just give me all the username facts. And then if the display name is different from the value, or we have any other number than 1. So it could be that we don't have a username yet. Let's go ahead and record it. It could be that we had a concurrent edit. Well, let's go ahead and resolve that. And then we create that username fact if there's a difference.
And then an auto context follow-up is I could see somebody not being sure, oh, do we need to keep this user information in the same immutable architecture as the other info? When you speak briefly to why you would continue to eat your own dog food, so to say, through all the parts of storage instead of just saying, well, that we just overwrote because we weren't really trying to keep the history on that part.
Yeah.
Is that making sense?
Yeah, absolutely. Yeah, that's partially to do with exactly what you said, eating my own dog food, just making sure that this is absolutely always going to work, or more importantly, knowing when it isn't going to work, because I know that in some cases it won't. But yeah, the practical reason that you would choose to do it this way would be that maybe you've got a social site, so you are interacting with other users. So in your specifications, you are like getting the messages from those other users, and then you want to know the names of the people who sent those messages. So having it in the model makes it possible to just join that all together inside of the same specification. Versus if it were outside of the model, then you would have to stop at the user hash or something like that, or the username or the user identity, and then look it up elsewhere. So, yeah, this makes it easier to have all in one.
And just for the record, I wasn't trying to be dismissive of your own dog food. This is clearly artisan dog food. And so actually when I saw it, I was like, oh, I wonder, before I knew the answer, it was like, I wonder if he uses the same immutable architecture for this. So it's complimentary, not... So anyway, go on.
Oh, I appreciate the question. Yeah, that's why we're doing this, is to have an open discussion about what are the advantages, disadvantages, caveats with this architecture. Yeah. So So yeah, after we've logged in, this query here that's getting the actual facts, that's the query that we just saw here, because this one gets the actual facts. This query here that is getting the values, that's a different specification happening in a different component. So if I take a look at this is going to be in the frame. We've got the header, which has the user component. That's where it lives. So looking at the user component, we can see here is names of user. Very similar looking specification, except this one selects the username.value. So that way, when we do that watch, then every time we get a result, we just set the string state to that particular name. So, so again, this is an example of you might have a concurrent edit. You might have multiple names for the same user, and last one wins. That's the one we're going to display. Which, in a sense, is me just being lazy and understanding that there's already some code that's going to resolve those conflicts when they happen. But that's why we see two of these, is these two components are rendering at the same time. So the optimization would be to recognize that that selecting the value doesn't change the feed, and so it should collapse these both into the same request. And you can see in the response they're both getting the same feed, the SUZ feed. It's the same one in both cases.
Okay.
So now it does optimize from there. So you can see these are the two requests for
Michael,
those feeds.
but so the result from that feed that we get is just the hash of. Was that the hash of that fact?
It was the hash of the feed that that then will satisfy the specification. To be specific about it, it will provide the evidence for the client to run the specification.
Okay, and where do we see that?
Yes.
That hash again.
Yeah, so we see this SUZ show up right here as another request. So this is the request to feeds/SUZ.
Okay.
And this is a get, so there is no payload. There is a bookmark parameter that initially starts as blank. And then we get back a set of tuples.
Okay. And there we have the hash of the username.
Yes. So when it generated the hash of the feed, it also remembered the specification. So now everybody can just fetch from that feed, and it'll run that specification.
Okay.
Which, by the way, is we're looking forward to better infrastructure underneath this architecture. You can imagine that this call to feeds will create a Kafka topic. And then it has that, it knows that specification feeds into that particular topic. And now these subsequent requests are just pulled from that Kafka topic. And now the bookmark advances along that topic. So this abstracts us away from particular infrastructure decisions which we can improve in the future. But right now, this is running a SQL query. So what it's returning is an array of tuples that satisfy the specification. So this tuple, there's only one of them, so it's an array having 0. And the elements of that tuple are the labels on these unknowns. So if I had more clauses in this, then it would have a fact that satisfies U1, and then a fact that satisfies U2, and all of the unknowns.
Yeah.
So I get those back. And then I need to actually load that particular fact into the client-side database. So the server gives back the hashes because the server doesn't know if the client already knows about that fact. So this is allowing the client to do a little bit more optimization on its side. So we see we've got the fetch from the feed, which follows both of these two feeds completing. So it kind of collapses that down into one fetch. So it dedupes those feeds. And then when that finishes, then it's going to then turn around and load the facts from the server. Now, after it started, you can see that some other fetches started in parallel. So this is one of those optimizations I was talking about last week, where it's going to kind of collect a whole bunch of fetches from feeds. And it says, okay, wait a minute, I'm not going to load quite yet. Let me get some more hashes in memory so that I can do one load with all of those hashes. And that's why this load here only starts after a few of them have come back. And this is that 100 milliseconds I was talking about.
Then these other feeds, so the 73, the 95, are these all
Yes.
feeds then?
Yes. So these are additional feeds. These came from this particular specification.
Okay.
So this one's a
Yeah.
bit more complicated. And this is the specification that we built for this list. So given a user, give me all the replicators where not deleted. Then for each replicator, give me the environments and the names, as well as the hash and the identifier. But as far as the server is concerned, you're going to work those out on the client side. I'm going to be giving you all the evidence. So,
Okay.
so yeah, when I optimize it, the client's not going to actually even tell the server that it's interested in the hash and the identifier. It'll say, yeah, I understand.
So if you go and look into the preview tab, then you see
Yep.
all the hashes.
Yeah, so these are the hashes for the 6 different feeds that are necessary to provide evidence for that particular specification. So the reason there are 6, we can kind of work this out with the specification. One of those, probably the first one, is the set of all replicators where there does not exist a delete. So so once you delete a replicator, that replicator fact no longer appears in that feed. Which means you would never learn about those deletes unless you had another feed, and so that's the second one, which is all the deletes for those replicators for the user.
Yeah.
And then you've got another pair of feeds because you have the same pattern here for names. So all of the replicator names, and then all of the successors that remove those names or replace those names.
For the environment, you mean?
Oh, yeah, pointing at environment. Yeah. So yeah,
Okay.
environment is the third pair. So yeah,
And
you end
then
up with 3 pairs of feeds.
Okay. And so, for example, if later on I change the name of a replicator, I can just ask the feed again with that same hash,
Mm-hmm.
and with the bookmark of the latest
The latest tuple. Yeah.
yeah.
Yep. And
Okay,
then
and
it,
based on yeah,
yeah, and
then
then
I
it'll
get
give you tuples that have occurred after that bookmark. Yeah.
okay, and based on the hashes that I get back then, I do a load to get all the fact information.
Yep. Exactly.
Okay. So then that 100 milliseconds, we have all the feeds there. Okay.
Yep. So yeah, at this point, it knows that it hasn't finished fetching all of the feeds, but 100 milliseconds have passed. Let's go ahead and load what we have. When it does finally finish fetching all of the feeds, then it does another load right here. So this one is coincident with the tail of that one.
So the 100 milliseconds is between the start of the first feed and the start of the first load.
It's actually between the end of the first feed that returns and the start of the load. Because until the first feed returns, it doesn't have anything. So
There's nothing.
yeah.
Yeah.
Yes, I think I probably pointed to the wrong range. It's actually from here to there.
Yeah.
Yep. So here you see it's loading. Let's go take a look at the hash that it gets back at first. So 6pk is the original username that it gets back.
Yeah.
And so when we do this load, by this point, my mouse battery is definitely in need of replacement. Okay, so by this point we have a few facts that we want to load, but 6pk is among them.
Yeah.
And so yeah, as soon as that returns, then it loads those into the local database, and then it says, all right, I've fetched one batch from this SUZ feed, and I got back that first time, I got back a bookmark of 2. So let me go ahead and fetch the next batch. And so it does the get with the B query string parameter of 2, and that returns an empty array of references, same bookmark. So that's the server telling you, okay, you're done with that feed. You've read to the end.
You're up to date. Yeah.
Yep.
So the next one is okay. That's one of the previous feeds.
Yes.
With the new bookmark and the 95 also. Yeah.
Yep.
And
So
apparently one of them returned was not empty, so we have another load.
yeah. So yeah. First of all, with this QINQ, it finished here, and so it was included within that first batch, and so that was loaded in, and then as soon as the load was done, it went back for the second batch, found that it was empty, so it returned an empty array of references. By the way, the bookmark is a multi-part number, and I think we talked about why that is, but that way, with all these tuples, if new stuff happens, you can still batch within a group of similar tuples. But yeah, so it fetched to the end on both of these. Then by this time, yeah, let's skip ahead to this load right here. For this load, this one is coincident with the end of the rest of the feeds. So
you will get the information from the one as Z and the JWA. Because they both.
Yeah, the one that said
and the 95.
Yes.
Yeah, okay.
Yeah, all those would be in here. So this load, we should not see the interesting. We do have the. Oh, okay, yeah. And for this one, we're seeing replicator names that have come back. We're not seeing the username because we already fetched that one. So yeah, in fact, I think this is telling me that yeah, I'm wondering why I'm not seeing environments in that load. Interesting. These are all replicator name. Let's see where the environments come back. So that's the 9.5 where we already, well, did we already look at that one? SUZ was the username. Yeah, I think 9.5C was the replicators. Yes, this is replicator names that are coming back. So, so we can see how they are organized in tuples. It actually on the server goes ahead and flattens that that set of tuples because the client doesn't need to know how the tuples are actually organized, but the replicator just flattens them and gives you the distinct. Yeah, replicator names. Yeah, I'm not seeing the... Okay, here's the replicator environments. They were in QIN. So that means that, yeah, let's take a look at the timeline. They finished here, so they were actually part of that first load. Okay.
Yeah.
Yeah. Yeah, there they are.
Okay.
That explains it. Yep. So yeah, it keeps doing that until it's got all of the feeds exhausted and it has all of the distinct facts loaded into its local database.
So this 100 milliseconds optimization is something that you modified in Jinaga server, and in fact, it has nothing to do with the replicator setup.
Actually, I did that optimization in Jinaga.js, so it's the client side that's doing that batching before it talks to the server. But you are correct; it's not part of the replicator's application. So everybody gets that optimization.
And then if we go further to the... Okay, that's just
yep, so that's the end.
repeat JW, yeah.
Yeah, so it's loading the new ones here and then checking these two and finding that they have been exhausted.
Okay, that's the first time we really see the feeds working live.
Yep.
For the first time I remember.
Yes. Yeah, that is true. I've envisioned this pattern for several months now, and it's like, okay, it's finally actually rendering on the network tab, doing the right things.
Yeah. So every specification every specification will be potentially separated in multiple feeds. There is a not exist clause. That will be a separate feed.
Yes.
Okay. All right.
Yep. Yeah. The thing that's just really exciting to me is as I was working through and separating, just this concept of separating the specification into feeds, it followed logically from the way the specification is constructed, that this is all the evidence that you need in order to be eventually consistent. And so when I hear people talking about, how do I set up my Kafka feeds in order to to have to solve this particular problem, and so you've got some things coming from this feed and some other things coming from that feed, and how can I make sure that I get a consistent result at the end when I'm fetching from two different feeds? Kafka only has guarantees within one feed, and so people reason through and come up with solutions for specific scenarios. This is a solution for the generic scenario, and this would work perfectly with Kafka. It relies only upon the guarantees that Kafka already gives you.
Yeah.
So yeah, I'm looking forward to the day when I actually put Kafka underneath this, and then we can handle extremely high load. Right now, because this is backed by a SQL server, the load is going to be capped.
But so, for example, the sequence, if the client would miss one of the facts,
mm-hmm.
then the bookmark is not updated.
Yeah. So if the client misses a fact, there's a couple of ways that you might mean that. If the client makes a fetch for a feed, but so it says, okay, give me this feed starting at bookmark 0, and this request fails, so it doesn't get the response back. So now it doesn't have a new bookmark, and so the next thing it's going to do is say, hey, let's
ask for the same
this.
bookmark again.
Yeah. Now, the second way in which you might mean the client misses a fact would be that if something is inserted into the feed, but somehow during their fetching, it's timed just right that they kind of jump over it or something, and that is why the bookmarks are these multi-part identifiers. So like this one here, 11.9. So in order to insert a new fact, the server is going to be inserting into a SQL database in this case, and it's going to get the next identifier, the next integer in that fact table, and so then when it puts together the tuple, it gets the fact IDs of all the elements in the tuple, and then it sorts them so that the largest ID is at the beginning. So what that means is when you insert a new fact, you're going to be getting a new bookmark. If that new fact is part of a tuple that contains other facts, then its ID is going to be the one that's first. But you'll still be able to page through the results. That one fact might unlock a whole bunch of tuples, and you'll still be able to page through those results because their IDs appear later in the bookmark.
I don't really follow here.
Yeah, that was a a
Can you
complicated one to kind of reason through. So in
just
this particular case,
a simple picture would be nice
yeah,
in this case.
yeah, um, duh, duh, duh. Yeah, I think so.
A whiteboard on the wall behind you.
Well, well, here we see the results of this fetch were some replicators and some environments. So the the replicator facts uh, are inserted into the database, and since they're predecessors, the replicator is inserted before the environment is inserted. So for each replicator environment pair, the the environment's going to have a larger fact ID than the replicator.
Yeah.
So perhaps these were, and because we know that we're saving the replicator, the environment, and the name all at the same time, it's probably that one of these replicators, perhaps this one here at the end, got ID 9, the name got ID 10, and then the environment got ID 11.
Okay.
So, so that means that the maximum IDs for the elements of the tuple, since this tuple just has two elements in it, the replicator and the environment, the maximum IDs ended up being 9 and 11. So it's like this one, yeah. So the one before that would have been, probably 6 and 8, and then the one before that was probably 3 and 5. So we've got 3, 5, 6, 8, 9, 11 are the tuples that are coming out. So it flips that order so that the 11 comes first. So that's why we're seeing the 11.9, and then it's taking the largest of those of the tuples that it gets back. So the reason that it's doing that is that, let's suppose that that I've done a whole bunch of work on a replicator, and so there's a whole bunch of facts related to it. I set up authentication, all this stuff, and then I invite you to join me with this replicator. Say, okay, I want you to be able to develop against this one and push new models to it and all that stuff. So so I send you an invitation. That invitation is itself a fact. So maybe that invitation gets ID 12. So you get this invitation in your feed, ID 12. So you're going to start with a bookmark that starts with 12 dot. But then you've got all of this history to catch up on. All of these other facts that were related to that particular replicator that I just invited you to join me with. Mm-hmm. So all of that history has its own IDs, but they're all earlier than 12 because that history already happened.
Yep, they're all predecessors.
Yep. Well, yeah, in fact, in this case, they're all successors of the replicator, but you didn't know about that replicator until I gave you the invitation. So yeah, you've got a zigzag. I'm inviting you to this replicator with this history. So the history is successors of the replicator, but it happened earlier in time than this invitation.
Okay.
So they have earlier IDs, but they're not causally related to the invitation because you have to go up and then back down. So yeah, there's the diagram, the zigzag. So in order for you to catch up on all that history, you need to be able to fetch all of those successors from the feed. Now there might be more than will fit in a single page. So you need the bookmark to be able to cut somewhere inside of that history. So as soon as I send you the invitation, you don't get just one new tuple in your feed. You get a whole bunch, and they all have a consistently increasing, a monotonically increasing bookmark starting with 12. And then the rest of the bookmark is the the rest of the IDs that are part of that history. So you'll fetch all of that history, then you'll be done with that invitation for 12, and then you can move on from there.
Okay,
So
that's
the hand wavy description of it.
so if you have all successors predecessors, you only have one number, and at the moment that you have not causal related facts, then you have two numbers or more numbers.
Yeah, you'll end up with two numbers as soon as you have two elements in your tuple. But yeah, when it's not important until they are not causally related. But yeah, it doesn't use that causal relationship in order to give you a shorter bookmark. Just follows a simple algorithm to generate the bookmark, and that's based on the number of elements in your tuple. And it determines the number of elements in the tuple by the labels. So yeah, in this case, we're talking about the environments. So there's a feed that gives you a label U1 and U5. And that's the feed that we were looking at. It doesn't include U2 because it's already got the where not exist clause. U2 does not exist. So it's just giving you U1 and U5. Yep, that is the protocol. So yeah, for next week, I will make sure that I've got Visual Studio Code working so that we can actually go through the documentation that I've started for
the SQL
for the SQL
generation.
protocol. Yeah, and SQL generation. So yeah, that and so far what I've got is the very simplest example, walking through the different steps and finally generating the SQL, but just for feeds. So that includes the bookmarks that we were just talking about.
Okay. So actually, what I was asking today, you prepared it more or less.
Yeah.
I have some good news for you.
Mm-hmm.
You're not alone in having troubles. Actually, I just I just started the Linux WSL, and it tells me error 0x800. Press any key to continue. I tried to do yesterday something with Scrapey, from a tool for web scraping.
Mm-hmm.
So I blow it up apparently.
Yeah, I managed to upgrade on my laptop. I think it did run through a similar issue on the laptop, but I already solved it there. So it's solvable. Probably just takes a reboot to get it solved.
This is strange because I wanted to see on which version I am. I thought I updated to .NET 7, but now I have another problem.
Mm-hmm.
WSL is still not very stable, I have the impression.
It's a hard problem. Let's run two operating systems in one.
Because one of the things, if I have a virtual machine running, my main system, a virtual machine, in that virtual machine, I run WSL.
Mm-hmm.
if it stays open for a while, several days, and then I put my computer to sleep, and I boot up, sometimes, I think it has to do with Windows updates, the whole computer crashes.
Mm.
The blue screen of that, which beside that I never saw on Windows 10, and only in this case I get it. So
Wow.
there is still something.
Yeah.
But okay.
Yeah, that's one of those reasons that I try to avoid virtual machines. As a consultant, it's pretty hard to avoid virtual machines, but yeah, I am able to get most of my stuff done without them. But yeah, of course, now with Docker, it's a lot easier to avoid VMs because you're not really avoiding them. They are still running, but Docker is managing them, so you can just shut them all down, start them back up, and they tend to be smaller. A Linux machine that just runs Postgres, just runs Elasticsearch, just runs Redis.
Okay. Next week, the same time?
Yes, next week, same time.
Okay.
And
So
let's hope this same time forever. So,
forever.
yeah.
Okay. Good. Michael, thank you very much for all these useful explications. And see you next week.
All right, thanks, Jan. See you then.
Bye-bye.